Okay, now we just have 2 more layers of the sun to do, and then there's one little thing I want to talk about after that. So let's finish this up. There's a problem with seeing the other 2 layers of the sun, though. Can anybody figure out why it is hard to see the layers of the sun that are above the photosphere? Why is it so hard to see them? It's a pretty simple reason. Don't overthink it. I like how you guys are thinking, but so the layers above the photosphere do emit visible and UV light and all the kinds of light that we're talking about. It's just that they don't emit nearly as much as the photosphere. So the photosphere is just so bright that our eyes can't adjust to see the other parts of the sun. We even have a hard time picking it up on telescopes a lot of the times. So in order to see the rest of the sun, you need to block out the photosphere, okay? And that naturally happens sometimes. What do we call it when the photosphere is naturally blocked on the sun? Yeah, it's called an eclipse. So one of the very few times you can see the layers of the sun that are above the photosphere is during an eclipse. But we can artificially fake an eclipse inside of a telescope by blocking out just the photosphere from our images. And if we do, we get images that look like this. Oh, forgot to switch it over. Let me switch back into my PowerPoint. There we go. Here is an image of the sun with the photosphere blocked out, okay? And you can see here that there's sort of a bunch of darker looking patches here. That's because those parts have been blocked. That's photosphere peeking through. So this is the next layer of the sun, and you can kind of see up here, you know how little kids draw the sun and they draw that fire around it? That's kind of a representation of this. If we were to zoom in real close on this part of the sun looks like fire, okay? So when we draw it in our diagram, let's draw it looking kind of like fire. Here we go. So the next layer of the sun's going to look like this. And it's called the chromosphere. And the reason it's called the chromosphere is that it is, a lot of people consider it to be very colorful. Chromo means color. It's much thinner than the photosphere. And if you were to take a guess, would you expect the chromosphere to be hotter or colder than the photosphere? Would we expect the chromosphere to be hotter or colder than the photosphere? If you were to guess. Yeah, you'd guess colder. But this would be one of the times where our guess would be wrong, because it turns out that the photosphere is actually the coldest part of the sun. The temperature down in the core is in the millions of Kelvin. It drops down to about 5,800 when you get to the photosphere, so still hot enough to kill you instantly. But when you jump to the chromosphere, it goes to 25,000. So photosphere is about 5,800. The chromosphere is 25,000 Kelvin. So it's hotter than the area just below it. And the reason for that is because of how it's composed, how it's made. Let me again go back to this picture. Here we go. If you look right here, this is a zoomed in picture of this. And if we look right here, again, see how it kind of looks like a fire right here? The chromosphere is made of hot jets of gas called spicules. And that's spelled S-P-I-C-U-L-E. Spicule. S-P-I-C-U-L-E. Spicules. And again, they're hot jets of gas bursting through the photosphere from below the photosphere. So the reason that this chromosphere is hotter than the photosphere is that the gas that makes up the chromosphere is bursting through the photosphere from below. So it comes from a hotter region of the sun. So it stays hotter as it shoots out through the photosphere. Does that make sense? Okay. Now, in order to see the very last layer of the sun, you have to block out the chromosphere. And if you do, you get a picture of the sun that looks like this. So all of this, everything that they're coloring red or orange or yellow here, all the way out to here, is the last layer of the sun. And unfortunately for these times, awkward time now, a little bit awkward. Does anybody know what this layer of the sun is called? It's the last layer of the sun. Yeah. Yeah, it's called the corona. It's called the corona, spelled just the same as the coronavirus. So what can you do? But it's named the corona for the same reason that the coronavirus is called corona. Yes, the sun has corona. Why do we call this the corona? Why is the coronavirus called a corona? And why is this thing called a corona? Yeah. Corona means crown. So you can think of it as around the sun's head is this jagged area, kind of like a crown. And if you ever look at a picture of the coronavirus, it also has like a jagged area around it. That's why it's called a coronavirus. It looks like it has a crown, right? So that's where that name comes from. So let's draw this onto our picture. This is a very big, layer of the sun. It's the last one for our diagram. It's very big and very misshapen. It does not keep one shape to it. So I'm just going to kind of draw a big lumpy mess here. It doesn't keep one size, and it doesn't keep one shape. It continuously changes in size and shape between twice as big as the sun out to 3 times as wide as the rest of the sun. It's a mess, right? And then up here in our diagram, this is just outer space. And I'll also take a picture of this diagram and post it up in the Discord in case you can't see the writing very well in the stream, okay? Now, what is the corona like? The corona is the thinnest layer of the sun by far. It's extremely thin. If you were floating around in it, you probably wouldn't even see it. That's how thin it is. But it is also even hotter than the chromosphere, okay? It is about 2 million Kelvin, okay? So let's figure this out. Let's look at this. Check this out. If we look at all the layers, the core is the absolute densest, and as you go up, everything is less and less and less and less dense. That makes sense. But for temperature, the core is the hottest, and then the temperature drops until you get to the photosphere, and then it gets hotter and hotter. Now, why is the corona so hot? We don't fully understand why the corona is so hot, okay? It is not well understood. We're still trying to figure that one out. It seems hotter than it should be based on a lot of our models, but we're working on it. I'm sure we'll figure it out without, it's not going to be something that it takes us hundreds of years to figure out. We'll figure that out. Now, 2 million Kelvin. If you could somehow block out the entire sun, except for the corona, like we just took the corona and put it somewhere else at 2 million Kelvin and kept it 2 million Kelvin, and you went in it, you would die, right? You would die. Why would you die being in the corona? Why would you die being in the corona? Even if the rest of the sun wasn't even there. Let's assume you have air to breathe. The corona is very hot. The next thing I'm going to say is not going to make a lot of sense at first. If you were to go into the corona by itself, you would freeze to death. I'll let that sink in for a second. It's 2 million Kelvin. If you went into the corona all by itself, you would freeze to death. Let's figure that out, okay? Let's figure that out. To help you figure out what's going on, I think somebody actually has figured it out, but let me give you guys a different situation. Let's say that you were in your kitchen and a crazy person broke in. You were like cooking something in the oven and you were boiling some water for some pasta, and a crazy person came in and said, you have to stick your hand you have two choices: stick your hand into the oven for 5 seconds or stick your hand into the boiling pot of water for 5 seconds. Okay? Which one are you going to put your hand in? Would you rather put your hand into the oven for 5 seconds or put it into the boiling pot of water for 5 seconds? Hopefully, you guys are saying the oven. Looks like you're saying the oven. And the reason for that is this. It's not necessarily because the oven would be a lower temperature. In fact, your hand would be fine in the oven even if the oven was a higher temperature than the boiling pot of water if you spend the same amount of time in them. Why would the boiling pot of water be able to heat your hand up, let's put it this way, more efficiently? Why would the boiling pot of water be worse? It's the density. That's correct. It's the density. The density is what's happening. So when something heats you up, it has to touch you to give its heat to you, okay? When you stick your hand in a boiling pot of water, you're going to be hit by billions and billions of hot particles per second. When you stick your hand in the oven, because the air is not as dense as the water, even if the air was hotter, you're going to get hit far less often. And so your hand does not heat up as fast.